Hello and welcome to this lecture on understanding Salt. In this section, we'll be delving into the Salt framework. We'll unravel the intricacies of SaltStack, exploring configuration management, understanding how Salt operates, and delving into concepts like InfrastructureAsCode and Idempotency. So, let's dive in. Back in the days when configuration management tools weren't widely used, even a simple straightforward task like installing a package on multiple servers posed a significant challenge. The reliance on manual labor prompted people to resort to creating complex shell scripts to automate these tasks. However, scripts came with their own set of challenges. One major hurdle was the diversity of servers with different distributions and operating systems. Each server utilized different commands to execute the same task. For instance, installing a package in Ubuntu involved using apt, while in Red Hat it was yum. Creating a script capable of handling tasks across various distributions proved to be complex, demanding, and required a deep understanding of the scripting language, often consuming a considerable amount of time. Instead of writing complex scripts or managing logging into every server to execute a task, we can use a simple configuration management tool like SaltStack, which automatically takes care of the complex ordeals we had to face while using shell scripts. Now, we don't have to worry about writing a complex script, which handles minute details of different commands and flags used in different operating systems. SaltStack has a built-in resource called SaltState, which automatically takes care of these details. This makes our task so much easier of just writing the code without being bothered about different commands and flags diverse operating systems use. As demonstrated here, installing a package on a server, whether it runs Ubuntu or Red Hat or any other distro, can be achieved with just a few lines of SaltStack code. Did you notice how effortlessly SaltStack simplified the task of installing packages? Instead of grappling with intricate scripts, it streamlines the process seamlessly. Now, there might be a case where you want to remove a package on a server. You need not to worry. The solution is again to run a simple and robust Salt code. This time, just replace the installed function with removed function, without thinking about changing anything else. All other things, including commands and flags, will be taken care by Salt. Here's another useful example for installing and managing the Apache application using SaltStack. For those who may not be familiar with Apache, Apache is a widely used and highly popular open source web server that serves as the foundation for many of the world's websites. This straightforward SaltStack state file simplifies the installation of Apache package, the configuration of Apache configuration file, and the initiation of the Apache service. You can apply this state file across different servers or environments requiring Apache application, and it automatically manages the application's configuration without any need for manual intervention. So, what InfrastructureAsCode stands for? InfrastructureAsCode, or popularly termed as IaC, is a method where we configure, manage, and provision our IT infrastructure through machine-readable codes. Instead of manually configuring servers, networks, or other infrastructure components, we express the desired state of our infrastructure using code. In simple words, configuring and managing your infrastructure with code-based file is called IaC. In our case, we have bundled multiple manual steps together in form of Salt code, which is nothing but InfrastructureAsCode. Now this code can be applied on one server or hundreds of servers in few seconds. With SaltStack, we write code in YAML to define the state we want our infrastructure to be in. This includes specifying the installation of software, configuring server settings, and more. SaltStack then uses this code to automatically ensure that our actual infrastructure matches the defined state. The benefits of IaC especially with SaltStack, are substantial. It brings consistency by enabling us to define and replicate infrastructure configurations consistently across different environments. Automation is a key advantage, as IaC automates the deployment and configuration processes, reducing manual effort and the risk of errors. Additionally, IaC enhances scalability and promotes collaboration among teams. Now, to understand the concept of idempotency, let's look into a simple analogy. Imagine standing in front of an elevator. You want to go to the 10th floor, so you press the button for the 10th floor. The elevator lights up, acknowledging your request. Now, would pressing the 10th floor button again magically teleport you to the 10th floor? No, it wouldn't. The elevator would simply register your request again, but it wouldn't make it move any faster or make any change. This means that an idempotent operation would yield the same result no matter how many times you perform the operation. In context to SaltStack, idempotency means that the result of our SaltStack code will remain same no matter how many times we run it. In the earlier example, where we configured an Apache application on our minions, the code ensures the installation of package, configuration of files, and having Apache service up and running. Irrespective of the number of times we run the code, the results won't change. That means if the package is already installed, the configuration file already configured, and the service is already up and running, SaltStack will refrain from making any alterations, ensuring a stable and predictable system state. Now that we have understood how Salt performs configuration management, let's try to understand some basic terminologies used in Salt. You need not to worry about them too much, as we will cover them in depth in the later sections. The Salt Master is the machine that controls the infrastructure and dictates policies for the servers it manages. It operates both as a repository for configuration data and as the control center that initiates remote commands and ensures the state of your other machines. A service called Salt Master is installed on the master to provide this functionality. The node that Salt manages are called minions. A service called Salt Minion is installed in each of these managed machines and configured to communicate with the master. Salt masters and minions by default communicate using the 0MQ messaging library. This provides extreme high-performance network communication between parties, allowing Salt to send message and data at rapid speeds. Because 0MQ is a library and not an independent service, this functionality is available in the Salt Minions daemons natively. The Salt Master communicates with the minions using an AES encrypted 0MQ connection. Communication is done over TCP ports 4505 and 4506, which needs to be accessible over the master server only. Modules are the basic building blocks which executes at the backend to perform underlying tasks in Salt. In simple words, modules are pre-written Python programs in Salt. Though there are various categories of modules available in Salt, but execution modules and state modules are most popularly used in performing most of the automation tasks. Execution modules are used to perform ad hoc tasks from the command line against one or more minions. State modules in SaltStack provides instruction for configuring servers, ensuring consistency and automation. State files use state modules to define and enforce desired configurations for servers and infrastructure. Salt state is a declarative or imperative representation of a system configuration. .sls files are described as a set of desired states that a system needs to be in. For example, Apache needs to be installed and running. Top file matches formulas and Salt pillar data to Salt minions. The hierarchy of SLS files in Salt is called state tree. Jinja Templates allow Salt files to be written in a more flexible manner. We'll explore more about it in the final section of our course. Salt comes with an interface to derive information about the underlying system. This is called the grain interface because it presents Salt with grains of information. Grains are collected for the operating system, domain name, IP address, kernel, OS type, memory, and many other system properties. This allows Salt to understand and interact with our minions better. Pillar is an interface for Salt designed to offer global values that can be distributed to all minions. These secure variables are defined and stored on the Salt master and then assigned to one or more minions using targeting. Salt SSH runs Salt modules over SSH on systems which don't have Salt minion. Salt call command is used to run modules locally on a minion instead of executing them from the master. Salt call is used to run a standalone or masterless minion and was originally created for troubleshooting. So, in this lecture, we discussed how Salt performs configuration management, what do we mean by infrastructure as a code, how Salt code is idempotent and essential Salt terminologies. That's it for this section. See you in the next one.